Now, in this video, we are going to take up one more problem on the projections of solids. The problem reads as a square pyramid 35 mm sides of base and 60 mm axis length rests on HP on one of its slant triangular faces. Draw the projections of the pyramid when the axis is inclined to VP at 45 degrees. To do this, so first I have to how to analyze this problem. So to do that, first we will go for the initial position. See, he says one of the triangular faces has to rest on HP. So obviously that triangular face has to be perpendicular to VP. So if I want the triangular face to be perpendicular to VP, that means you have to get the triangular face or a vertical, you have to get a line in the front view. So which is the triangular face which we are talking about? We are talking about O dash, A dash and D dash. Which is that? When you look from the top view, OAD is a triangle. Similarly, OBC is one more triangle. So both are the triangular faces which is perpendicular to VP. Since it is perpendicular to VP, then how to take the initial position in the top view? The initial position has to be the base edge. This is how you should analyze how to place the initial position of the solid when you want the triangular face or the slant edge has to be resting on HP. Now, here, since a square is a even number, so the edge opposite will always be a edge. Once if your resting edge is perpendicular to VP, that means that the triangular face will become perpendicular to VP. Now, how to, this is how you will be able to fix the initial position. And now, how to start creating the drawing on manually. First, we will going to draw the XY line and you mark VP and HP. So then you measure 35 mm and draw a square on the horizontal plane. So you mark these points as A, B, C and D. Join the diagonals AC and BD with a dark line. These two diagonals will going to intersect at this point and you mark that point as O and O1 in bracket. As you look from the front view, you can see the height of the pyramid. So you draw a vertical projector from both A and D to the XY line. Similarly, from B and C to the XY line. Then draw a vertical projector from O1 and take it to the above XY line. Then from the XY line, you measure the distance of 60 and you mark this point. And you mark that point as O dash here and O1 dash in bracket here. Then when you look from the front view, A and B are near to the observer, so A dash B dash is visible and C and D is away from the observer. Therefore, C dash and D dash is in bracket. Then join O dash to A dash with a dark line because visible to visible is visible. O dash B dash is a dark line because visible to visible is visible. And A dash B dash with a dark line because visible to visible is visible. So then join between O dash and O1 dash with big dash and small dash. And you make a dark line between O dash, A dash, B dash and B dash O dash with a dark line. Similarly, ABCD, you draw a dark line, then diagonal AC and BD with a dark line. Now, how to see, when you look from the front view, I can see all the base edges are resting on HP. So, obviously, that will be in true length in HP. That is, AB is equal to BC is equal to CD is equal to DA, which is equal to 35 mm. And when you see here, O dash, B dash, C dash is one triangular face and O dash, A dash, D dash is one more triangular face. How do I know that? When you look from the front top view, OBC is a triangle and OAD is also a triangle. Therefore, it is the triangular faces. In other words, if a solid has to rest on HP on a triangular face, make that triangular face perpendicular to VP. In other words, the edge containing the triangular face has to be perpendicular to VP in the top view. So this is how you will be able to analyze it. Then he says one of the triangular faces is resting on HP. Since O dash, A dash, D dash is one triangular face and O dash, B dash, C dash is the another triangular face. And if you want to keep it on O dash, B dash, C dash, then you rotate it in clockwise direction. If you want to keep the triangular face O dash, A dash, D dash on HP, then you have to rotate in counterclockwise direction. Because both those two edges are, both two surfaces are the triangular faces. Then in this case I am doing B dash, C dash, O dash on HP. So what I need to do is you draw this XY line further. Then by using the compass you measure the distance from B dash to O dash and you consider any point on the XY line and you mark that point as B dash and C dash. Then by taking the radius of B dash O dash with B dash C dash as center, cut an arc on the XY line and you mark this point as O dash. Then similarly you measure the distance from B dash to A dash by using the compass. From B dash you draw an arc and then you measure the distance from O dash to A dash. From O dash you cut on the previously drawn arc and you mark this point as A dash and D dash. You mark this point as B dash and C dash in bracket and here it is O dash. Then you measure the distance from B dash to O1 dash from the first position front view and transfer it from B dash on B dash A dash line to cut it here and you mark that point as O1 dash in bracket. Then join big dash and small dash on O dash O1 dash line. So once you do that, you have this is how you will be able to write the second position front view. Now to this I need to write the top view. How to do that? Draw a vertical projector from B dash and C dash and draw a horizontal projector from both B and C. These two lines will going to intersect at this point. You mark that point as B and A. Similarly, draw a vertical projector from O1 dash and draw a vertical projector from O dash and draw a horizontal projector from O1 from the initial position top view, and these two lines will going to intersect at this point and this point. You mark this point as O1 and you mark this point as O. Then you draw a vertical projector from A dash and D dash to the XY to the top view and draw a horizontal projector from A and D. These two lines will going to intersect at these 2 points. You mark that point as A and you mark this point as D. Then how to then join between A to B, B to C, C to D and D to A with a thin line, and join between OA, OB, OC and OD with a thin line, and you mark this as O1 with a big dash and small dash, which is the axis line. Then join O to A, O to B, O to C and O to D with thin lines, and join between A to B, B to C, C to D and D to A with thin lines. Then you apply the condition of visibility. All the exterior edges of the boundaries of the solids are visible. So that means BC, BA, OA, OD and DC are all forms the exterior edges of the boundaries of the solid. So you dot them. Then when you look from the top view, the entire rectangular face is visible, that is A dash, B dash, C dash, D dash is visible. So AB, BC, CD is already visible, therefore you make DA also becomes visible. You can see that DA is also becomes visible. But then what happens to the position of OC and OB? Since OC and OB are crossing the visible edge AD, so since two visible edges can never cross each other, so that means once AD becomes visible, OC and OB will automatically becomes invisible, because two visible edges can never cross each other. So you apply that condition. Once you do that, you can see that OC and OB will automatically becomes invisible. Since the entire portion of ABCD is visible, therefore O1 will become visible. So this is how you will be able to write the second position top view from the first position. Now the next condition is the axis will be inclined to VP at 45 degrees. What does that mean? Since the axis is inclined to VP at 45 degrees, so that means he has given the true inclination. But what you got here, O1, is the apparent length. Why? Because once the triangular face is resting on HP, therefore the axis will automatically becomes inclined to HP. Since the axis is inclined to HP, therefore in the top view that axis will be in apparent length. But the inclination given here is the true inclination. Therefore, from the projections of lines on the apparent length, you have to get the apparent inclination. But since the second position top view you have the apparent length, therefore in the third position I need to find the apparent inclination. So to do that, consider any point and then draw a horizontal line. Then you mark that point as small o. Then with reference to that center, with reference to the horizontal line, you measure an angle of 45 degrees and then draw an inclined line. This one. As this axis is parallel to VP, therefore in VP you will going to get the true length. I can take the true length of this axis or you can take the true length of this axis because both the axes are parallel to VP. So you measure the distance of 60 with O as center, cut on the 45 degree line, then draw a locus line. Then you measure the distance from O to O1 of the second position top view with the same center O. You cut an arc on this locus line and you mark that point as O1. Then join O1 with the big dash and small dash line, which will going to be the axis line. So on this apparent inclination, you rewrite the second position top view. So how to do that? Then you measure the distance from O to this point. From O, you cut it on that beta inclination line. Then with reference to this OO1 line, you draw a perpendicular here. Similarly, you extend it on this side and then you measure the distance from O to this line, and from O you cut an arc on that beta inclination line. Then through that point you draw a perpendicular to this OO1 line, that is the beta inclination line. Then you measure the distance from this point to A, which is same as this point to D. So from this point you transfer it on this side and also onto this side. Again you come to this extended line here with same center. You cut an arc on this side and also from this side, and you mark these points as A, B, C, D. And you join all these lines including the dotted lines and the visible lines and the axis as the same. You rewrite the same sketch. Once you do that, now I need to write the front view. So to do that, draw a vertical projector from O to the XY line, and you draw a vertical projector from B to the XY line, similarly from C to the XY line, and you mark all these 3 points as O dash, B dash and C dash. And similarly draw a vertical projector from A to the front view and draw a horizontal projector from A dash and D dash. Similarly draw a vertical projector from D, and both these two lines will going to intersect at these 2 points, and you mark these 2 points as A dash and D dash. Similarly draw a vertical horizontal projector from O1 dash from the second position front view and draw a vertical projector from O1. So these 2 lines will going to intersect at this point. You mark that point as O1 dash, then join O dash O1 dash with a thin line. Similarly draw a vertical projector from C and B to the XY line. So mark those 2 points as C dash and B dash, then join. Then once you do that, now I need to join all these edges including the slant edges by thin lines. So then join between A dash to B dash, B dash to C dash, C dash to D dash, D dash to A dash with thin lines. Then join between A dash to O dash to D dash, O dash to C dash and B dash is already joined, and join between big dash and small dash with O dash and O1 dash. So this will going to be the axis line. Now we will going to apply the condition of visibility. All the exterior edges of the boundaries of the solids are visible, that is A dash, D dash, D dash, C dash, C dash, B dash, B dash, O dash and O dash, A dash with a dark line. Then the surface near to the observer is visible. So when you look from the front view, this entire the square surface will going to be visible. Since A dash, D dash, D dash, C dash, C dash, B dash is already visible, therefore A dash, B dash will also becomes visible. So the entire surface is there to the observer. Then what happens to this edge? This edge will automatically becomes invisible, that is O dash, D dash becomes invisible because apply the condition, 2 visible edges can never cross each other. Since A dash, B dash is a visible edge, therefore O dash, D dash will automatically becomes invisible. Since all the portions of A dash, B dash, C dash, D dash is visible, therefore O1 dash is visible, and join between O dash with O dash and O1 dash with big dash and small dash line, which is the axis line. How do I know that my problem is right? Even in the final position, you can see that the triangular face O dash, B dash, C dash is resting on HP. Since the triangular face, once the triangular face is resting on HP, the axis becomes inclined to HP, so you have got the apparent length. And since you are rewriting the same sketch here, so I need to find the beta inclination, that is the apparent inclination. On that apparent inclination line, we are writing the view. And since one of the triangular faces is resting on HP, and this is a square of 35 mm side and height of 60 mm. So this is how we will be able to analyze and solve the problem manually. And then how do I know that my problem is right? Even in my final position, you can see that the triangular face is resting on HP and the axis appears to be inclined. The axis is inclined to BP at 45 degrees. So I need to find out the beta inclination. And since it is a square of 35 mm side and the height as 60 mm. Since we have considered all the data which was given in the problem, and hence our problem is right. Thank you.